almost everywhere you look, there's uses of AI and machine learning. The basics are by having the machine crawl through all of your information, you can come up with much better decision making. And you can't do that even with a huge staff writing queries. And that's why the big boom.
Technology is transforming how we think, how we lead, and how we win. From InterVision, this is Status Go, the show helping IT leaders move beyond the status quo, master their craft, and propel their IT vision. Welcome to Status Go. I'm your host, Jeff Tunn. Since HAL in 2001, A Space Odyssey, and later The Terminator, Hollywood would have us believe that we will soon be controlled by robots. But Hollywood aside, artificial intelligence, or AI, brings with it the ability to change our businesses and change our life. Today, our guest is Mark Plaskow, a senior consultant, author, speaker, innovator, connecting, utilizing data, warehousing, analytics, and AI. Welcome to the show, Mark.
Thank you very much, Jeff. It's a pleasure to be here to talk with you about technology and modern technologies like artificial intelligence and machine learning.
I know our audience can't see Mark, but he is, what's the term, the doppelganger or whatever the term is for the spitting image of someone? He is Mark Cuban, guys. I'm telling you. If you see him face to face, he looks like Mark Cuban. I'm sure you've heard that a million times, Mark.
It's actually the first time today, Jeff, but
first time today. That's right. Well, it's early yet. It's
the
early.
day's still pretty young, so I'll give it a couple more time. I certainly wish I had timed the .com bubble like Mark Cuban did. But,
yeah, no kidding.
I think I'd beat him in a game of basketball or most things. But he, certainly has made a lot of money as a brilliant person. And
absolutely,
it's only got me a couple free beers, and yeah, I'm sure I'll hear it again before the day's over.
Yeah, I'm sure. So, Mark, the term artificial intelligence or AI has been with us for quite some time now. But it seems like in the past few months, everyone is doing AI, or at least claiming to be doing it. What is your definition of AI, and how does that differ from machine learning or algorithms?
So, yeah, I'm pretty sure that Judgment Day is a little ways away, Jeff. So if you're stockpiling groceries in your basement, I think you're going to be okay for a little while before the machines start nuclear war.
That's good to know.
But let's differentiate between artificial intelligence and machine learning a little bit. The power of artificial intelligence is the ability of the machine to make predictions. Some of the work I've done in the past, with malaria in Africa for cancerous disease, is the ability to predict what's going to happen, to predict human behavior, to predict speech. To me, that's artificial intelligence. It's creating an intelligence of its own that is predicting, mimicking, or making decisions, active decisions. And that would be what AI is. And it's become much more popular recently because of the power that's been seen in it. It's just as human beings, we cannot process through as much information, train ourselves in as much information in order to make accurate predictions as the modern machines with their computing ability can.
So if that's AI, then what's machine learning?
That's a very good question. So machine learning is where they learn to take over the human race and to wear ties like us and go to work and argue with their spouse and all the things we do every day. So machine learning to me, Jeff, is the machine learning over large amounts of data. Okay, so it's not an active kind of intelligence. And I actually like the term machine learning a lot better than AI. AI is a big buzzword. But it goes through, we call epochs, thousands and thousands, millions of iterations on data, and uses mathematics, what's called matrix algebra, uses mathematics to get to the proper result the most often, assigning a weight and a bias to all of its inputs, basically. Okay. That is machine learning for me. It's more of a cold, concrete going over and over and over data and being able to figure out exactly how much priority every parameter or piece of data has in order to get to a certain outcome. An example would be in medicine and healthcare. So machine learning, if you can imagine IU Health, where I am right now, Community Health, the Cleveland Clinic, they could employ 500 physicians, 1,000 physicians and nurses, any number of healthcare professionals, and they would never have the ability to crawl through all of their patient information, to take every parameter in and to analyze it in order to find out the exact mathematical formula or combination to predict, hey, Jeff Ton might have a cardiovascular event. Mark Plaskow needs to be screened for prediabetes. That to me is machine learning, and that is the real, one of the clearest, in my mind, examples of the power of it. We could spend the rest of our lives writing SQL queries against data and never be able to cycle through these iterations or epochs, changing the weight and the bias every time until we mathematically get to the right answer. And that is the real power of it and why every organization needs it and wants it.
I wanted to dig in to some of the work you mentioned it earlier, the work that you've been doing in AI to identify diseases. Can you take us through that journey?
Sure. I felt a calling. I did some breakthrough work with Children's Hospital, Nationwide Children's Hospital, initially for cancerous diseases where pathologists said, hey, this is how you define finding cancer. And no one was able to really do it on the team. They tried with it, and my wife would tell you I'm very stubborn, or I feel like, hey, what a great challenge. And so I was able to do some work to very accurately predict cancerous disease, and then was very, very lucky to have some medical mentors like Jerry Penn, who came out of Rochester way back and then went to Panama and was with the U.S. Army and was their lead doctor, one of the most brilliant medical people in the Midwest. And also now Frank Lloyd here in Indianapolis, over 35 years as an oncology surgeon, become a very close friend and business partner. Have medical mentors who taught me how to find disease, and then went to Africa and trained a technology to find malaria in kids and was able to get to 100% what you'd call sensitivity. So if 100 kids came in and were positive for malaria, which, as you know, there's a terrible and a killer disease, I was able to find all 100 of them. And then if 100 kids came in who did not have the disease, I was able to say, hey, 92% of them do not have this disease, but 8% of them need to be reviewed, which is where the AI at that time, which is before the modern convolutional neural networks and techniques, that's where it was at that time. And by saving lives in Africa and building a portable automated microscope that we could take into any house, any hut, any village, anywhere in the world, put a battery on it, it felt like I was meant to do, what I was meant to do.
Yeah.
With the AI, the images, if the AI wasn't sure, I could press a button and it sends an image back to Jeff Ton in Indianapolis, Indiana, and he can say, well, that kid's definitely a positive for malaria or for sickle cell anemia or for malnutrition or for thalassemia or filariasis, all those diseases there. And, that's going through regulatory and still, to me, the best calling that I could ever have using artificial intelligence and using what I can do because of the tangible number of lives it can save in developing countries and here for cancerous disease, diabetes.
I think it's interesting that there's still the human touch, the human intervention, human validation step in that. That's an interesting point, because I think so many times we think we're just, again, to go Hollywood, we're just turning it all over to the machines, and that's not the case. There's still that human correction to the model, right?
Absolutely. A cyborg of Arnold Schwarzenegger is not going to be able to go anytime soon and practice medicine in Africa or South America or Asia. You're absolutely right, Jeff, that artificial intelligence and the machine learning is only as good as A, the data, B, the training of it. And there are so many anomalies with medicine, especially, and I know we're going to talk about other industries, that with healthcare, that you need that human component. I need Jeff Ton back in Indianapolis, Indiana, even if I'm in the Peace Corps and I mean really well, and I'm in the bush in South America. I'm on the Amazon River, where I did a little bit of work too, in a village. And I think it's Chagas, which is a terrible parasite disease down there, but I'm not sure. You guys are medical professionals. I press a button and it comes back to you, and you can save lives all the way around the world.
I was not aware of your work on the Amazon. That will be a conversation for our next time we get together for coffee.
Sure.
I read the book Theodore Roosevelt's River of Doubt and his trip down the Amazon. So we'll get into that at a future coffee, man. But I want to get back to the humanness of this thing. And one of the things, and I don't think you and I have spoken about this, but it's all the buzz right now, and that's bias in algorithms. How do you make sure that the models don't get embedded with some sort of bias as they're looking at different things? Have you done much work in that area or thought much about that?
Yeah, I'm fortunate to work. I've teamed up with some other people like Richard Linares at MIT, who's literally a rocket scientist who worked with NASA and did the trajectory of the satellites. And, brilliant guy, has won all kinds of awards and has been my mentor for artificial intelligence, really. And really has left a lot of that, other than his teaching at MIT, to fight disease with myself and the rest of my team. So we've done a fair amount of work on this. And you're absolutely right, Jeff, and that's good. In addition to writing books and reading books, you've been reading up on some of the inherent problems with artificial intelligence and machine learning, which is biases of specific models. You've probably heard the term overfitting. If I train an AI model to find malaria and I train it on 1,000 kids, but they all have malaria, I'm going to have a tremendous bias in my model towards predicting positives for malaria.
Right.
So there are a couple approaches, and I don't know how technical you want to get for your listeners, but we use what's called ensemble training is one thing. So ensemble training means that you train several models. Let's say so we just did a CMS AI challenge with some researchers from Lilly, any biosciences that we were looking at. And we knew that if we just did let's say a straight deep learning neural network, we were going to be very dependent on specific parameters. And if they weren't there, let's say a patient's age or a patient's weight, whatever it is. And if those parameters weren't there when we had our trained model, we were going to have real problems with our accuracy. So we decided, okay, we're going to use a couple models. We're going to use what's called a random forest technique, which in essence is a huge decision chart. Okay, each decision it makes is really called a decision tree in order to come up with a prediction or whether it thinks a patient is going to be readmitted in this case or not to the hospital. We're going to use a principal component analysis, which picks out the very most important parameters about that patient and utilizes those in order to get to a prediction of them being readmitted. So that's one way you deal with it, is called ensemble training, or using multiple models. And then to get a little more complicated, you can then train those models and say, okay, we've got the trained models. We are going to call each model and get a prediction back. And we're going to go through 500,000 records and say, hey, you know what? We should give 70% weight to our random forest model. Does that make sense? And 30% to our principal component model, or our neural network, our deep learning model, whatever it is.
Yeah.
And the other ways that we do to prevent overfitting is that we will train on a subset of the data. So typically we'll take 50 or 60% of the data only and train on it. So I have samples coming in. Let's say I'm a company that provides technology services and storage, and I want to be able to classify my customers so I can better help them with whether they need cloud storage or they really need data storage in our locations, or they need on-premise. What class is this? Because Intervision, as an example, has all kinds of customer data out there, that you can train from and learn from
Right.
in order to be able to classify. That's really always the output of artificial intelligence, machine learning, usually is a classify a customer before you even meet with them and say, hey, I think these are what your needs are. So you'd use 50%, 60%, whatever of the existing customer data. Then you would validate your accuracy, let's say on 20% of the data, say, okay, for this 20%, our AI classified the customer the same way we do, or maybe whatever. Okay, you would validate on 20% what your accuracy is. And then usually we leave, and this is newer, but we always leave another 20% that it's never seen before. And then you'd take 20% of like new customers that the AI model hasn't seen before, and you'd run it against them to get your classification.
Gotcha. So there's that feedback loop, and I guess in some way, what we were talking about earlier about the human intervention, when you're not sure and you have a human verify the data, you take that information and you feed that back into the model or the algorithm to make it quote unquote smarter. Is that kind of the concept? It's constantly learning, and you have that human intervention, the human eyes on it to make it smarter.
Yeah, I think you summarized it pretty well, Jeff. Yeah, I think that's true. And to be honest, you've probably heard the buzzwords supervised and unsupervised learning, right?
Mm-hmm.
So supervised learning, almost every AI model or that I look at, we start with supervised learning. So you're an expert at cloud storage, at helping customers properly configure how they should store their information, access it, be able to scale it, those kind of things. If you were building an AI model for, let's say, your storage organization, you would be a good person to classify all of your customers and say, this customer has, 40 systems people and is about a 50-person company and has this many transactions a day. They're going to be profile C of a medium-sized customer that we think should store their data remotely to enable it to scale, but does not need to virtualize their laptops or any of those things. And there'll be another profile, which is this is a huge customer for us, and their profile A, and they should move everything to our cloud capabilities, and they should virtualize every one of their laptops to make it repeatable for all their people wherever they are. And you would be supervising the learning, right? You being an expert at that, Jeff, would train it on what the classes are. And then, only then, when it knows, okay, then it would train towards this is class C customer, this is class A customer, this is class B. That's supervised learning. Okay, and almost every model I see starts with that because the machine doesn't know going in usually, really, there should be 7 profiles of customers and they should all fit. And these are exactly how we're going to determine them. The machine has no knowledge going in. So unsupervised learning, the unsupervised part of it would be as it goes, it learns that, hey, you know what? It's not the size of the company or their revenues or their technology savvy. It's their personal relationship with Jeff Ton. That stands out as the parameter, which is overall positive usually, right?
Sure. We'll go with that.
So what's their personal relationship with a salesman or their geographic location, their zip code, those turn out to be the most important and key parameters that determine whether or not they make a decision or determine what kind of structure they should have.
Gotcha.
So that's the unsupervised part where the machine either creates or assigns value to parameters by its training.
You've talked a lot about the medical application of AI, and we've talked a little bit about making that cloud decision. What are some other uses for AI that you've seen in businesses today?
Yeah, really almost everywhere you look, there's uses of AI, machine learning, and we talked about the power of it. The basics are by having the machine crawl through all of your information, your historical information, you can come up with much better decision making. And you can't do that even with a huge staff writing queries. And that's why the big boom. So, trucking's a perfect example. So you can use AI to optimize your routes, which saves a lot of expense for the company. You can use AI to optimize your load on every truck. If I'm in manufacturing, optimizing my inventory, knowing exactly when I need to refill my inventory based on historical data and based on predictions from the AI. More and more, they're using visual AI to look at their warehouses and to make sure things are aligned.
Mm-hmm.
If I'm in finance, being able to find fraudulent transactions, right? Mark Plaskow spends money in $5 increments within 15 miles of his house. And all of a sudden, I go outside that and I get flagged. Insurance is a huge one now. What's my risk for every policy? What is my stop loss where I'm going to be losing more money on a policy than gaining, and I should end it? When should I settle with someone? Because what's the prediction of their length of injury and the total cost? Auto racing. There is a big one
Yeah.
in Indianapolis. What's the optimal configuration of my car? And this is obviously an industry in a sport I don't know. But I go back, and for the last 50 years of Indy 500, okay, the top 15 finishers, it turns out that the most important thing is their choice in tire durability, or their torque, or their steering, whatever it is, and being able to predict how to build a race car that's meant to win the Indy 500.
Those are all fantastic examples. A lot of our listeners out there are IT professionals, CIOs, senior IT leaders, and they're the buyer of a lot of these technologies. And it seems like every software company on the planet right now claims to be doing AI. How is the CIO supposed to separate the hype from reality? What are some questions he or she can ask to help determine, is this real AI or is it AI washing? In other words, they're just rebranding something that they've always done and calling it AI today.
Yeah, it's a buzzword, and all software development shops want to talk about it. So, part of it is the data. And I think if Dr. Linares were on here with me, he would say the same thing, that it's only going to be as good as the data, being able to take the data of your organization and what's called normalize or clean it in order to participate in proper AI training and models. So anyone who doesn't start with that is probably does not have a lot of experience with this. You and I could write a neural network, Jeff, in 4 or 5 lines of Python code. We could do a deep learning neural network, or we could do a convolutional neural network, and we could assign how many hidden layers it has. But our output would be, without knowing the data, the industry taking the time to learn it, taking the time to take all of the disparate data. You know a lot about this too. You see organizations with all kinds of differing data.
Right.
I've got HR data over here, and I've got finance data, and I've got operational data and sales data. And I've got to make them all take an apple and map it to an orange in order for it to really be a comprehensive AI training. So that's one thing. I tried to break it out into kind of 8 easy steps. And more, a lot of the modern CIOs are doing some homework, which is good. Getting a familiarity with AI, machine learning, and data science. Knowing, I see most things as machine learning, but that AI really is more of an active, actually gained intelligence that it's using and learning. Identifying the problems you want it to solve. That's the key thing, right? In the end, artificial intelligence, machine learning is inputs and outputs. So for an insurance company, they say, we want to find our riskiest policies. The first thing is, what are the inputs going to be? What do you know about every insurance policy or every claim or every customer? And then what outputs do you want? So what problems do you want to solve? Identifying those. And if they say, well, the only output I want is a prediction of the risk, great. If the output I want is what we'd call a clustering output, where I want to break my customers out into different profiles and groups, great. So that would be, probably the second one is clearly identify the problems you want to solve. prioritize, for concrete, tangible value. You've written actually a fair amount on this, on clarifying deliverables and IT projects. So being able to set in concrete, what are my priorities,
Yep.
and organize the team and give them clear outputs. Acknowledge that you have internal capability gaps. I had a conversation with one of the largest health systems here in Indianapolis, and they said, hey, we want to be able to create our own models against patient data. We acknowledge that we have younger people that are trying and really want to do this, but that they don't have the experience with clinical healthcare data. They don't have the experience with preparing data for AI and models, and they only want to do one type of AI model. So acknowledge that you have that capability gap. Number 5, I would say bring in experts to set up a pilot project. Start with, it's just the time saved by people who've done a fair amount of these projects that have expertise here, and that also will take the time to really learn and understand an industry, understand your inputs and outputs in your industry, people with enough expertise to know that they need to understand the data and then help you organize the data, and then start to get your first machine predictions and AI models. Have an internal team that's really dedicated to it, to integrate data, to learn from anyone you bring in, to learn from the experienced experts, so that your task force moving forward can modernize and move your organization forward with very accurate decisions by building AI models. And also, to have a dedicated effort, not to poke at it with a stick. I've never met an organization that says, no, we're not doing any AI or data science. But when you peel back the onion a little bit, most of them, you'll find that they have old school algorithms or data, or they are not truly using modern technologies the best way they could for their organization. So starting simple, start with clear, clean deliverables, a profiling of my customers, a clustering algorithm or clustering model to break out my customers into what type of storage plan is best for them, will work best for them, and give them the best ROI, or a ranked sales for salespeople based scientifically on their percent of closing a sale based on historical data. So I come into work in the morning and I have my sales sheet right there for me in order of predicted success based on machine learning against all kinds of historical data. So start with something clean and simple, and then plan how you're going to incorporate artificial intelligence as part of your daily task. How am I going to, every day, starting usually with reports that help you make decisions, start to incorporate it in your organization so that you can gain that leg up on competitors and on other organizations who aren't using it properly. For a physician, starting simple, what patients should I screen? Who should I bring back in? Because these important parameters about that patient have changed. Their time between heartbeats has gone up. Their blood pressure has changed. Their weight has changed dramatically. And I know through my machine learning that it's going to have X effect, likely, so it's time to bring them in for a screening. Also patient treatment plans, so that a doctor knows when a patient comes in, what should we talk about? Hey, Jeff, I know that where we left off, you were having a lot of joint pain and possible inflammation. How is that? Because it knows the chances are, hey, Jeff may be headed towards some arthritis or inflammation or pain or whatever. So, so those are just some examples.
Those are great steps. And to our listeners, I hope you were writing them all down, because there were 8 steps in there. But Mark, before we wrap up here today, what's the one thing that they should do differently tomorrow when it comes to AI or machine learning?
I think educate a little bit and start to talk to people, start to seek out people who can help. But I think that's the first thing. And then define what problem they want to solve.
Right. That's excellent. I think that's actionable, to go out and learn about what is AI, what is machine learning, gain an understanding of how it can be applied in your business or industry, and then determine a problem to go solve. That I think is a great first step for everybody listening. If you have an additional question or you want to learn more, you can go to intervision.com. The show notes will provide links and contact information. This is Jeff Tunn for Mark Plaskow. Thank you so much for listening.
You've been listening to the Status Go podcast. You can subscribe on iTunes or get more information at intervision.com. If you'd like to contribute to the conversation, find Intervision on Facebook, LinkedIn, or Twitter. Thank you for listening. Until next time.